Everyone, welcome to the simulation class. In this short video, we're going to solve one of the lab problems. So first of all, I want you to pause this video in order to read carefully the problem description, and then I'm gonna discuss like how is the structure and the configuration of the system that we're going to model today. Okay, so once you have read the video, so now you have an understanding of our model. So let's go over it together. So we have a grocery store. In that grocery store, there are three checkout lanes. We have like three resources and three queues. Shoppers arrive at the checkout area, and the inter-arrival time has an exponential distribution with mean 2.4. There are two types of customers. So those customers they have like a different processing time. So 1/3 of the customers, the processing time it's an exponential distribution with mean equal to 3 minutes, and the rest of the customer, 2/3 of the rest of the customers, the processing time it's 8 minutes. So once we have defined the processing time of each customer, then we know that with a probability of 1/3, they are assigned to one lane, and there are three lanes in total. So one important fact is that the type of customers that we have in this system, they are assigned to any of the three lanes. So it's a mistake if we assign like one type of customer to just one lane. So here there are no dedicated lanes. So each clerk will be able to handle any type of customer. Okay, and we're gonna run this model for 30 days, and everything's gonna start idle and empty at the beginning. It means that there are no queues at when time is equal to 0 at the beginning of the simulation. Okay, so let's start solving this model. Let's build the model associated to this system. So part A and part B. So we want to build the model, and we want to animate this model. So let's start. Okay, so we go to Arena, and let's start with the create block. So for the create block, we know that customers are arriving with and the arrival time. For the arrival, there is a probability distribution and exponential with mean 2.4. So the type it's random expo, and the value is 2.4. Be careful with the units. By default it's in hours, but in our problem description we know that the arrival time is in minutes. And this per arrival is just 1, and the max of arrivals it's infinite. Okay, so far we have defined the interval time, but now we need to assign the processing time to each customer. Please notice that the processing time is different. It depends on the type of the customer. So in order to assign that processing time, we need a decide here. So we know that 1/3 of the customers they require an exponential distribution with mean equal to 3 minutes, and the other 2/3 of the customers they require 8 minutes. So we're going to use two-way by chance. So we know that this is the 1/3. It's 100 divided by 3 because it's in percentage. If it's false, so that includes the 2/3 of the customers. So in case that this decide is true, it means that the processing time it's going to be an exponential distribution with mean 3. So we're going to assign an attribute. Just assign the name that whatever name you think. I'm going to use proc time, and the new value will be expo. and the mean is equal to 3. If you don't know the name of the distribution, with a right click, you can build an expression and you will find all the possible distributions that we have in Arena. Let me show you here, for example, random distributions. So you have gamma, normal distribution. In our case, we're using the exponential one, so it's expo. Okay, so expo, and the mean is equal to 3 minutes. Now we need to assign the processing time for the other 2/3 of the customers. So we're going to use an attribute, we're going to use the same name. This is very important because when we're defining the process for the clerks, we need like the processing time. So we need to have the same name of the attribute that carries the processing time, because clerks, remember that they are going to serve any type of customer. So you cannot differentiate like the name of the attribute. The value is different, but the name of the attribute is the same. So we're going to use proc time, but in this case it's expo, and the mean is equal to 8. Okay, so once we have defined the processing time, now it's time to send our customers to the checkout area. So in order to assign them to each lane, remember that there is a probability of 1/3. So we need a decide. In this case, we need a n chance, n way by chance. So it's 100 divided by 3. 100 divided by 3. And the false will take care of the other 1/3. Okay, so now we're gonna add the process. We're gonna add 3 processes. If you wanna assign a name, that's fine, like checkout number 1, checkout number 2, that's up to you. We're gonna define the logic as a seize, delay, release, because we're seizing the resource. Then there is a delay, which is the processing time, and once we have processed each customer, then we have to release the resource. Let's create the resource. In this case, we have clerk. I'm going to define clerk 1. And the quantity is equal to 1. This quantity is not the number of clerks. This quantity refers to the number of clerks that are required in order to process one entity. So in this particular case, for one customer, we just need 1 clerk. So the quantity here is 1. And now for the processing time, we're going to use an expression. Remember that we have defined previously the processing time, units in minutes. So we're going to use the proc time. This part is critical, and as I told you before, you need to have the same name for the attributes. In case you don't remember the attributes, you can easily go back to your assigned blocks and check the name of the attribute, or just with right click, go to build expression, and then on attributes, value. So you will find that the attribute that you have defined previously, in this case, the proc time will be here. Okay, so once we have created the first process, we click OK. So we can duplicate this process for the second clerk. It's important to change the name. Please notice that right now Arena it's like highlighting in yellow the second process block because they have the same name. So check out 2. Please notice that the resource is not the same. If we left the resource as clerk 1, the checkout number 1 and checkout number 2, they are going to use the same clerk. And that's not the model that we want to represent because we have like independent clerks. Okay, so let's change the name of the clerk, clerk 2. The processing time, it's an expression in minutes, and the name, it's the proc time. Okay, and let's create the third checkout area. Since delay release, we need to modify the name of the clerk, clerk 3. So we have defined 3 clerks. If we go to the resource module, you will find clerk 1, clerk 2, and clerk 3. It is once we assign the resources in each process block, so it is instantaneously created in the resource module. Okay, so now let's connect the decide with the process area. And once each customer is served, so now it's time to dispose that entity. All right. So once we're done with the logic, let's review it real quick. So we have an arrival time here. We're using a random exponential distribution with a mean equal to 2.4 minutes. Then we split our customers. So 1/3 goes to this assign, where we assign the processing time, and the processing time is expo with a mean equal to 3. And for the other 2/3 of the customers, we're assigning a proc time equal to expo with a mean of equal to 8 minutes. Once we have assigned the processing time now, we assign each customer to the lane. So for that, we're using a n-way by chance decide block, where each decision is given by the 1/3 probability. So we have 3 paths, and then we have 3 process blocks where we have assigned 1 resource per block. Please notice that the name of each resource is different, and the processing time is given by the attribute called proc time. Okay, so right now we're done with the logic, but remember that there are a couple of additional requirements. So we're going to run this model for 30 days. So let's go to run, set up the replication parameters. So there is just one replication. The replication length is 30 days. Time units, days. And the base time units, this parameter is very important because these units are going to affect the reports that are provided by Arena and also the plots. So my advice is that you should use as base time units. You should use the same units that are provided in the example, in the program description. So here, the interarrival time and the processing time, everything is in minutes. So my suggestion is that you should use minutes. So the result will be the same, but the only difference will be the units. Okay, so far we have defined the replication length, and we changed the base time units to minutes. So apply, and our model right now is good to go. But let's add the animation. So for the animation, I'm gonna move the cues. We're gonna add some resources, and we're gonna modify the entity pictures. Usually I like to add like a square. So let's start with the resources. In the animation panel, you will find the resource button. So let's click on the resource button. And the identifier means which resource do you want to animate. So let's start with clerk number 1. And then we have the states of these clerks. So in general, there are 4 states, but we're going to discuss just the 2 first states, the idle state and the busy state. So then we have different pictures. So feel free to select the picture that you want to represent each state. So for example, if you want to use like a green ball for busy and the red ball for idle, vice versa, that's up to you. So in this case, that we want to like animate clerks, let's find different pictures. So if the picture that you want is not here, so you need to click in open, and let's find another library where maybe we're gonna find a more suitable picture. So we go to libraries. This path will change. It depends of your computer and if Arena is installed in your computer or not. But the main idea is that you need to go to the Arena folder, and over there you will find a library with different pictures. So we go to Rockwell software folder. Arena. In my case, it's taking some time for 2 reasons. One, because I'm recording this session, and the second reason is because I'm using an online version of Arena. So this is like a network storage. Okay, so here is the picture library. And in this particular case, I'm gonna use the workers library. All right, so now let's find a good picture to represent clerks. So I think that these 2 pictures will work. So the first one will represent when the resource is idle, and the second one when it's busy. So if you want to assign it to each state, just click the picture, click the state, and with this arrow, you will assign the picture immediately. Okay, so we have assigned a picture for clerk 1. For the idle and busy state, you need to check the sys area. When you activate the sys area, you will be able to visualize the entity when the entity is being served. Okay, now we just click and place our resource. So if we want to duplicate the resource, we just need to copy and paste. But please notice that given that we have activated the sys area, there is like a small circle here. That's the sys area. So You can place it wherever you want, and in that sys area, we will visualize the entity when the entity is being processed. See, by any reason, we don't check the sys area and we don't activate that option. So once one entity is being served by the resource, we won't be able to visualize it. Okay, so let's create two more resources. This is going to be the clerk 2. And let's create the third clerk. All right. So now let's add entity pictures. So we know that we have two type of entities here, two type of customer. So let's use the animation panel again. And this is the button for entities. So basically I'm gonna use people for the entities. I'm gonna change the library. So let's open the same folder that we opened for the resources, but now I'm gonna use the default library, which is the basic process. Okay. So I'm gonna select two pictures. This in this picture, this guy looks like he has like a basket in his hand. So let's use this one and this one. Okay. So we have defined two different pictures. So let's assign a name for later. So this first picture, I'm gonna call it cost 1. This value that I'm giving to the picture is the one that I'm gonna use in for the assignment of the entity picture. So I know that this picture is cost 1, and the second one I'm gonna call it cost 2. So in the assign block, when I'm assigning the entity picture, I'm gonna use this name, the name that we have in the value field. This is the one that we're gonna use later. Okay, you can place it wherever you want. So in order to assign the entity picture, we go to our assigns where we are assigning the processing time, and here we're gonna add a new attribute assignment. In this case, we're gonna use the entity picture attribute, but the value is cost 1, and for the second one, we're gonna use cost 2. Entity picture, cost 2. Okay. So far for our animation purposes, we have created the animation of the resources and the animation for the entities. Now we need to add one plot and the clock. So let's add the plot. Okay, so for the plot, basically, I want to show you the program description again as a reminder. So far we built the model, and now we're working on the animation. So we have assigned pictures for the resources and the entities, and now we want to add the plot to keep track of the length of each queue. There are 3 queues, and we want to show a clock. Okay, so for this plot, I'm gonna add basically 3 variables. Each variable is the number in queue. So we are in data series. Let's add the first data series. So the name will be Q1. The expression means the variable that we want to visualize. So in this case, we go to build expression, Q, current number in Q. So you have to select which Q is the one that you want to visualize. In this case, it's the Q associated to the first clerk. So that's checkout 1 Q. Okay. There are other parameters that if you want to explore, feel free. Here is you will find a brief description of each parameter. If you want to change the color, that's fine. So let's add the other series. We need to add 3 in total. So the second one is Q2. Okay. So for Q2, we're gonna use the current number in Q. You have to change the Q name. In this case, it's checkout2.q. And let's add the third series. Let's call it Q3. And the expression, the old expression, Q, current number in Q, checkout 3. Okay, so far we have defined the source data for our graph, but now we need to give the information for the X's, the name, and the units. So let's enter the parameters for the x-axis. Okay, so you will find different parameters for each axis. So here, if you wanna modify the title, the label, the scale, the type of line, so you will find like a parameter for each modification. So here we're just gonna focus on the last two, on the scale and the title. So for the scale, basically if you want to define a minimum value, a maximum value, the increment, and the auto scroll. Those are like the main parameters here. So in general, my recommendation is to keep activated the auto scroll. The auto scroll basically means that if at any point the plot reaches the maximum, immediately the graph is going to rescale itself, so you won't lose that information from your graph. So let's keep it as true. For the maximum here, I'm gonna change it because remember that the x-axis here it's time, and given that the base time units is minutes, and we're running the model for 30 days, so you know that we have more than 100 minutes. So I'm gonna use 1000 minutes, even though I know that the number of minutes it's higher, but 1000 minutes is a good time to visualize. But we know that this plot is going to rescale, given that the auto scroll is activated. So I'm fine with the 1000 minutes at a time, and the increments I'm gonna change it from 10 to 100. Sometimes you don't know like the maximum values. That's normal because that's why you are running the model. You don't know like the values that your variables are gonna take. So my recommendation is like you should run your model first, and then you will modify these parameters. So don't feel bad if at the beginning your graphs are not working the way you are expecting, but you just need to keep trying until you find the correct parameter. Okay, so I'm gonna use the 1000 maximum for the x-axis. So right now the title, it's time, but it's not visible. Please, it's the value right now is false. So I'm gonna change it to true, and now you will see that here at the bottom. You will see the label for that axis. For the y-axis, let's add the title. I'm gonna call it NQ. Same idea here. If we want to modify the maximum, the minimum, I'm gonna change it to 50. If you wanna keep it at 100, that's fine. And the auto scale, it's active. So once we're done with the values and the labels, so let's click OK, and let's play the plot. Let's place it here. I'm missing the title, so if you want to add a title, you need to go here to titles. So we want to add a header, and the text will be number in Q or Q length. Okay. If you want to modify the size of the font, that's up to you. Okay. So right now we just need to add the clock, and we're done with the animation. So for the clock, there are two options. If you want an analog or digital clock, I prefer the digital clock. It's more clear to me because you're going to visualize the numbers. If you want to change the starting time, that's possible too. I just want to leave it at 0. And if you want to add a title, yeah, that's up to you. I'm just going to leave it as it is. So here we have our clock. And now we're ready to run our model. So in general, once you are an expert or like an intermediate user of Arena, you will run your models like in the maximum speed. But initially, my advice is that you should try to run your models in a low, in a minimum speed, just in order to make a visual validation. So let's run our model. You can appreciate the animation; it's working. Same idea with our graphs. So once we know that at least it looks that it's working, so maybe you want to increase the speed. As you increase the speed of your simulation, you won't be able to visualize the animation. That's normal. But please notice that the clock is running. Okay, so now that Arena has completed the run, so let's check the results. For this particular case, for the first part of this problem, we want to find these three statistics. We want to find the average of customer time in system, the mean and maximum time of customer in system. So basically, we're concerned of the total time of each customer in the checkout area. So let's go to the entity information. For this particular model, we just, even though we have two different processing times, we haven't changed the entity type. We just have one entity type. So entity 1, that's the name by default of that entity. So let's check the statistic for the time. So we are concerned here just for the total time, the average, the minimum, and the maximum. So for this particular problem, we want to find the average time, which is 58.19. Remember that we defined that the base units, it's minutes. So these quantities are in minutes. So we have found the average, the minimum, and the maximum. So let's go to our table and let's type those values because we're going to compare it with a second part of the problem. The average time is 58.18 minutes. The minimum time is almost 0. It's very small. And the maximum time is really big in this case, 347.79 minutes. In real life, maybe it's not realistic that a customer in a supermarket is gonna wait this amount of time. It's not gonna be, but in our example, let's say that it's possible. Okay. So now for the second part, management has decided to merge the lanes in a single lane. So let's modify the model above to match the new policy. Save your new model under a different name. So please save your model for the first part. And then we're going to use this file to create the second one, but you have to say it using a different name. Part A. Be careful where you save it. In my case, I didn't pay attention to the folder because it's not relevant, but for you it's important. So now I'm gonna save part B. Okay, so for part B, we're gonna get rid of this decide because we're not having 3 lanes anymore. So we are gonna have just one queue. So let's delete queues, the animation. We need to delete this process. We need to delete the decide. So in this new logic, once the customer arrives to the system, so once customers are in the checkout area, and once we have defined the processing time, so they go to the clerk, but there is just one queue. So now we have to modify our resource. This part is correct. We have one resource, clerk 1, but and where each customer is gonna use one resource, but we need to modify the capacity of the resource. Right now, if we go to the resource module, you will see that the current capacity is 1, which is not true, because that clerk 1 is gonna represent 3 clerks. So in order to do that, we need to change it from 1 to 3. So now we're saying that this is equivalent to say that there are 3 clerks. Okay. So you just need to check that the name of the lane of the queue is correct. So check out 1 queue, and the process is checkout 1, so it's correct. Let's check the animation for the resource. It's clerk 1. So here, please notice that the sys area for part A, we just had 1 point. That's because there was just one resource per lane, but now that we have 3 resources in 1 lane, so we need to increase the sys area. So just double click the sys area, and let's add more points. So we're gonna have 3 points in total. Okay, so let's play the 3 points. All right. So if I run this model again, I will have an error. Let me show you why. Because I'm using checkout to queue, and that queue variable is it doesn't exist right now. So if we click on find, it will show that in our plot we haven't deleted the series associated to Q2 and Q number 3. So let's go and let's delete those series. So let's remove Q2 and Q3. So now we're good to go. So let's run our simulation. I'm going to increase the speed. It's running. The fastest way to run a model is here in run, run control, batch run. Okay, so let's check the results. If you compare the number out for this second model, it's higher. For the previous one was like 17,000 something, and now it's 18,000. So let's collect the same statistics. So we have the average time, total time was 26 minutes, and the minimum and the maximum are different now. So let's bring these values to our table and let's compare with part A, and let's see if there is like any difference. Okay. So the new value, the new average total time is 26.26 minutes. The minimum almost zero again. And the maximum 161.4. Okay, so let's compare the values. So let's compare the average time. Please notice that we're reducing by a 50% approximately the average total time. So it means that the new policy affects in a positive way the system. So if you analyze like the differences of the first configuration and the second one, you will notice that, for example, in banks, they use the second layout where there is like just one queue and it's shared by all customers and it's served by all of the clerks. So in real life, yeah, it's possible to apply this type of configurations, but we also, if we think about the case of the stores, it's not that easy sometimes because if you have like a big long queue, so customers maybe they won't feel that good about that big queue, especially because everyone has like a shopping cart, so that queue is gonna be kind of messy, right? So in some cases, yeah, the idea of merge the lanes will work, but sometimes won't. That's why everything is not white or black. In this case, you will see that there are some supermarkets where they have like a mixed strategy. So they have some like independent lanes, but for customers with less than 20 items, maybe they have like 3 clerks serving just one queue in order to optimize the utilization of these servers. So for this particular case, we have proof that the single queue scenario it's better in terms of the average total time. So this is all for today. So I hope you have enjoyed this video. I will see you in the next session.